Hello again. We're going to just briefly talk about equilibrium and acid dissociation constants. So if you look at an acid that dissolves in water, so we've been looking at acids and bases and in water as well. Okay, we of course form our conjugate acid and conjugate base. Okay, if we were to calculate an equilibrium constant, so we did this a while back, when we looked at equilibrium. Okay, look, that means that we have this double arrow. The rate of the forward equals the rate of the reverse. Just a little review from previous videos. We take the concentrations, so in molarity, we know what concentrations are now, of our products divided by the concentrations of the reactants. Okay, so of our products over reactants. Okay, and so if we calculate this, so let's just pretend that we put 1 here, a 1 here, and a 1 here, then K would be equal to 1. And so we have a specific name for our equilibrium constant when we're looking at the strength of acids. And so we call this Ka. It's called, you can just think of that A as being for acid, and it's the acid dissociation constant. The only difference here is that we do not have to include water, the concentration of water, into our equation. So we take products over the reactants, okay, because you can multiply both sides by water, and that forms this new constant. So Ka is still equal to product concentrations over reactant concentrations, but you just do not include water there. Okay, when you calculate this for different acids, okay, the stronger the acid, the larger this Ka value is. Okay, so the larger that number, okay, if we think back to our previous video, we talked about how equilibrium is going to favor the side of the weak acid, okay, and the side where you have a smaller Ka value. Okay, and so if it favors this, so if the Ka is larger, okay, then it is favoring the side of the weak acid. So Ka values, just to give you some ideas, in my class you do not have to memorize these at all, but they're still really small numbers. Notice they're negative powers. Okay, and so if you look here at this acid, the hydrogen phosphate ion, okay, it has a -10 exponent there. Okay, it's a very small number. Okay, because these are negative, okay, this is going to be a much lower Ka value than the hydrogen sulfate ion that's here. Okay, so notice those are negative values, so this is a much smaller number, okay, than here. So as we move up, just like our other table we looked at, we increase in acidity. Okay, and so the larger the Ka, this number is larger than this number and this one, then the larger the Ka, the more acidic. Okay. All right, I hope this helps. Thank you.